Here it is, the last extra video. All right, so hopefully you had a chance to try to solve this. It's log base 2. That is a deliberate choice. All right, so when you have a number that doesn't have a log, but everything else does, get the everything else all to one side. So we're going to add that log base 2 of x minus 4 to both sides. Now, don't try to get all fancy, just write the 2. So you're very clear what you're doing on each line and why. So I have log base 2 of x plus 11 plus log base 2 of x minus 4 is now equal to 4. I cannot cancel the logarithms right now because I still have that plus. So what I need to do instead is merge these two logs. Log m plus log n. I can change this into a single log. Of the product. Now I have a single log equal to a number. Now I can use my exponential, my inverse operation. So on the right, 2 to the log base 2 cancel each other out. So I'm left with the x plus 11 times x minus 4. And we are going to have to FOIL that out in a second. And then over here, I have 2 to the 4th power. Well, that's 4, 8, 16. 2 to the 4th is 16. So it looks a little crazy, but now I have a quadratic. So this isn't a short problem, but it is a very comprehensive problem. So we will have x squared minus 4x plus 11x minus 44 equals 16. Quadratics have to be equal to 0. So I know I'm going to minus the 16. I am also going to merge these two, which will be plus 7x. And then this becomes negative 60. Now, again, if you don't feel like trying to factor this, that's fine. Quadratic formula will work. Just make sure you're very good at that. If you are not as comfortable with that, 60 has a lot more factors than that 3 we had in the previous one, but not so many. So anytime a number ends in 0, my brain automatically goes to like 6 and 10. It's negative 60, so I need to make the smaller one negative, so it adds to a positive. This adds to 4. So that means these two are too close together. So I don't want to try like 7 or 8. I want to go smaller than 6. So if we go with 5, 5 goes into 6 once. That leaves us 10 left over. 5 goes into 10 twice. Negative 5 and positive 12 will be 7x. So we have x minus 5 and x plus 12. That product is equal to 0. So one of those two things must equal 0. And again, like we saw before, it is possible to have a log equation with two solutions, but usually one of them is going to screw up. And it's usually, but not always, the negative. I can certainly write an equation where the negative number works and the positive one doesn't. So don't make assumptions. So we have two potential solutions. To check these, it's a lot of zooming out. We got to go back to the original problem. So log base 2 of our number plus 11 is supposed to equal 4 minus log base 2 of thing minus 4. All right, and let me cheat a little. I don't want it to go that far. All right, so we're going to check positive 5. And we're going to check negative 12. All right, so up here, 5 plus 11 is 16. Log base 2 of 16 is a number. 4 minus log base 2 of 1 is also a number. Down here, though, log base 2 of negative 1, no. It doesn't even matter what the other side is. That's a negative 1, that's a no. So our only solution is the 5. All right? So anytime you are finishing a log equation, you take those numbers back to the printed original equation, see if they give you a domain error. If you weren't sure and you just try to crunch this on the calculator should also go error. So now you know. There's our extra video. That's it. You guys got this. I believe in you. I'm proud of you for making it this far. And I'm proud of you for finishing this course out. Good luck in your future endeavors.